Good afternoon, good morning, good evening, wherever you are listening to me, both in Nigeria and diaspora. You are highly welcome to the Physics and Mathematics channel. This is Physics and Mathematics Dismantle channel. Today, I still have something for you on the physics. What is that? This is a dimension and analysis. What is dimension? What dimension is all about? The dimension has a formula. Does it has a type? Then what do you call dimension analysis? Let's go step by step. Dimension, go with me. This is what I have for you. What is dimension? Dimension simply means a power to raise quantity, a power in which a quantity is raised in order to represent a derived quantity. They represent the fundamental measurable quantity that describe physical phenomena such as length, mass, and time. Dimension is one of the suitable topics in physics that each and every student must not left out. Because if you don't understand dimension, simply means that you don't understand the fundamental, you don't understand the foundation of the physics. When I say dimension, it's just like a natural phenomenon that we use to represent, that we use to form equation, to correct equation, and to form that used to form a big quantity from units. When we are talking about unit, what is the unit? That is something of another day, but let me chip in some certain things. Unit is a standard code to identify a physical quantity in physics. Then when we are talking about quantity, another name for the quantity is nothing but parameter in physics. When we say quantity, is otherwise known as parameter. Now, what are the quantities we have in physics? We have physical quantity, derived quantity, and the dual quantity. That one will be the subject of the next time. Now let's quickly go. Then when we're talking about dimension, it is also used to check the correctness of the fundamental and standard equations in physics using dimension analysis. What is dimension analysis? When we reach there, you should be able to understand. It has formula. What is the formula for the dimension? MLT. What M stand for? M stand for the mass. What is the unit of the mass there? Kilogram. Simply means that anywhere you see a kilogram, then you represent it with capital M. You see, I didn't write it as a small m, it is capital M that we use to represent. This is what they call dimension formula. L stand here, it is representing length. Don't forget from the definition up there. Therefore, it is used. When you see from the word from this place, we said that to represent the fundamental measurable quantity that describe physical phenomena, such as what? Length, mass, and time. Length stand for time, L stand for length, while T stand for time. MLT is the dimension formula. And mind you, any moment that you want to do a dimension, when we reach to the analysis, when you reach to the physical and formula application, therefore you need to enclose it in this bracket. If you don't do so, you can see this is not a curly bracket that we are using in mathematics. Then you are going to use this simple bracket any moment you are doing dimension application. Then here is the meaning of the M. Capital M stands for mass, which is giving you a unit of kilogram. L stands for length, which will give you the unit of meter. T stands for time, which is going to give you the unit of seconds. Now, let's go to the types of dimension. There are three types of dimension. 1. Fundamental dimension. 2. Derived dimension. 3. Dimensionless. When we are talking about fundamental, these are the units. These are the dimension of a physical quantity that we can never furtherly classify. We can never furtherly divide. We can never furtherly do anything we read. It will be written as it is. Such as length, it is meter. L will represent the dimension of that. M is kilogram. M will represent that unit of those things like that. Now, to be continuing from here, we said three types of dimension. 1, it is fundamental. 2, it is derived. 3, it is dimensionless. Then what are the samples? We have thousands of samples, but for the fundamental, they were basic 7. One, it is mass. The other, it is length. The third one, it is mass. We have mass, length, time. Then you have temperature, which is represented by theta. We have amount of the mole, which is represented by N. And we have luminous intensity, which is represented by J, sometimes represented by high, but the acceptable symbolic, it is J, because we cannot use I for the luminous intensity, because it cannot be like a symbol of current. That is what we know as a hour current, which is represented by ampere, which is A, and sometimes we used to represent by high somewhere as well. Those are the fundamental units that will convert them to the dimension. And when you are writing them in a capital letter, it is not about dimension. Now let's go to the second one. The second one is derived. Every one of us know that the combination of two or more fundamental units will give us derived quantity. Then any moment you are combined two or more of this fundamental dimension together, then you are going to have something called derived dimension. Then when we talk about derived dimension, therefore we talk about quantity of a force. Then what is the unit of a force? We said Newton. Any moment that you want to find the derived unit of a Newton, it is kilogram meter per second square. Therefore, you should be able to dimension things outside there. Look at the speed. Then the speed is distance over time. Then distance is in meter, time is in second, that is meter per second. Then you continue to have something like that, and you dimension. When we reach to the dimension analysis, when we are doing the calculation aspect of it, then you should be able to understand it better. Then we continue on this. The third one, it is dimensionless. These are the dimension of a quantity that cannot be dimensioned. When I say dimensionless, it's something that we cannot combine it with any other thing. Sometimes they don't have unit. Sometimes their unit, it is constant. E.g., let's look at something called a refractive index as an example. Like this one, it is refractive index. What is the unit of a refractive index? Refractive index has no unit because it is apparent depth all over, real depth all over apparent depth. The meter, we cancel it. That is dimensionless. Look at a kind of a frictional, what do I call this? That is frictional constant. The constant of a frictional, that is the proportion, real, yes, if I'm not mistaken, that is proportional, the frictional constant. E also, that is the force all over normal reaction. Then the mu we have there, Newton over Newton, then that is what they call it dimensionless. Think of many of dimensional quantity. Now the last one, uses and application. Uses or application of a word of a dimension. 1. Dimension, it is used in deriving formulas. Yes, good. Now I told you, it is used for the correctness. It is used for the correctness of the equation. If you can see it here, that is correctness of the equation. We said deriving formula. We use dimension to derive formula. I will show you when we reach there. You should be able to understand it better. Unit conversion. Yes, we have different type of unit. You can combine them together in order to get the standard unit for that thing. Dimensionless analysis. When we say dimensionless analysis, therefore, when you are given a certain equation, when you are given something in kind of words, then you can try as much as possible to relate them together, and then you bring something out nice. Then understanding the physical meaning of a quantity. Understanding the physical meaning of a quantity simply means that any moment you derive, any moment you are given the words, and then they give you the illustration, and you be able to put it together, then you should be able to know that V equals to U plus AT. Then you can be able to know that F equals to 1 all over 2L into bracket of M all over tension. Those things like that you should be able to understand. When we reach to the second aspect of this, you should be able to understand why mean about dimension. This is the meaning of the dimension by the second aspect of this that we are going to analyze, that we are going to synthesize and massacre and dismantle so many problems concerning about dimension and how to calculate it as well. Then you will be able to understand what I'm saying. Now that is the end of today's episode. I really appreciate you for watching this video, wherever you are listening to it, wherever you are watching it. Please don't forget to like, don't forget to share, and don't forget to watch it, as I said, and make sure you subscribe to it. I pray that the Lord Almighty will be able to provide you knowledge and wisdom to overcome any likely problem in physics, mathematics, and all other subjects. Thank you so much.